Hello. The experiment we're going over today is batch reactor kinetics, as performed by Brandon Benavente, Casey Lamos, and Emad Alisai. Today we'll be going over the background, the equipment used in this experiment, and the procedure and safety to be taken into account. There are some key concepts that we're going to need to understand. These are the design of batch reactors, rate laws, and activation energy. Batch reactors are self-contained, agitated vessels in which reactant materials are added in certain amounts at discrete points in time. These type of reactors are also used for small-scale operation and production, and typically range in size from 5 gallons to 8,000 gallons. Batch reactors have the ability to perform at many temperatures, ranging from 20 to 450 degrees Fahrenheit, and at high pressures, up to 100 psi. They are relatively low in cost to operate. The rate law is the relationship between the rate of a reaction and the concentrations of reactants. The rate law expression for the reaction between crystal violet and hydroxide ions is listed here. The activation energy for the chemical reaction between sodium hydroxide solution and crystal violet solution can be determined by using the Arrhenius equation, listed second. This experiment bears three main objectives: to derive reaction order for crystal violet and hydroxide ion, to determine kinetic rate constant for crystal violet and hydroxide ion, and to note the effect of temperature on rate constant and reaction rate. Now, the most important topic to go over before performing any experiment is, of course, safety. Crystal violet, one of our main components, is a mutagen and should not be handled by staff who are pregnant. It is very toxic by inhalation or ingestion. It is an irritant. Acute exposure to the skin may cause irritation and redness. Also, crystal violet is a biological stain, so you'll want to keep it away from your skin and clothes unless you want that color there for a very long time. Exposure to sodium hydroxide solid or solution can cause skin and eye irritation. Direct contact with a solid or with concentrated solutions causes thermal and chemical burns, leading to deep tissue injuries. Next, we'll go over the equipment and materials used in this experiment. Our materials include several solutions, lab equipments, and several glassware. We'll continue to go over some specifics. First, we have a couple of caustic or sodium hydroxide solutions at known concentrations. We have our crystal violet solution at known concentration. We have our Vernier colorimeter, our computer interface, and Vernier temperature probe. Here we show our experimental apparatus. On the top left is the beaker where the reactants are joined together, which is then pipetted into a cuvette, and finally ends up in the Vernier colorimeter. Now we will go over the experimental procedure. Part 1. Finding the rate law. First, and most importantly, goggles and gloves must be worn throughout this experiment. Second, we will prepare the computer for data collection. Next, we prepare a blank by filling an empty cuvette 3/4 full with distilled water. Seal the cuvette with a lid, and make sure to handle cuvettes only by the top edge of the rib sides. Position the cuvette with the clear side facing toward the white reference mark in the colorimeter. Now prepare 4 cuvettes with known crystal violet concentrations. One sample should contain pure water, and one sample should contain pure crystal violet solution. The 2 remaining samples should be within this range. Next is to use a 10 milliliter graduated cylinder to obtain 10 milliliters of 0.02 molar caustic solution, and another graduated cylinder to obtain 10 milliliters of 2 times 10 to the negative 5th molar crystal violet solution. Initiate the reaction by mixing 0.02 molar sodium hydroxide with crystal violet and stir. Begin collecting absorbance data after 2 minutes in 45-second intervals for 20 minutes. Repeat this procedure for 0.01 molar sodium hydroxide solution. Part 2. Rate constant and activation energy. First, calibrate the colorimeter again as done in Part 1. Step 2. Ready the sodium hydroxide and crystal violet solutions for all 4 trials. Use a 10 milliliter graduated cylinder to obtain 5 milliliters of sodium hydroxide solution with a concentration of your choice. Use another 10 milliliter graduated cylinder to obtain 5 milliliters of crystal violet solution and transfer it to a screw thread vial. Repeat these steps until you have 4 vials of crystal violet and 4 vials of sodium hydroxide. Place 2 sets in the refrigerator and 1 in the freezer. The remaining set will be used for the first run at room temperature. Conduct the first trial by pouring the sodium hydroxide and crystal violet solutions into a 50 milliliter beaker. After 1 minute, record the temperature of the mixture. Fill a clean, dry cuvette about 3/4 full with the reaction mixture. Place the cuvette in the colorimeter and record temperature. Now collect absorbance data for 60 seconds. Repeat this for the runs at lower temperatures. You should shoot to have the temperatures of the 4 runs vary from approximately 10 degrees Celsius to room temperature. Thank you so much for watching, and go Bulls!